Last time we drew the cost as a valley and said we want the very bottom, the dials with the least error. Gradient descent is simply how we walk down to that bottom, and the scary name hides a very simple idea. Picture yourself standing on a hillside, blindfolded, and you want to reach the lowest point. What do? You feel which way the ground slopes down under your feet, and you take a step that way. Then you feel again and step again. That slope, which way is downhill and how steep, is called the gradient. The good news, maths hands us that slope exactly at any point on the valley, no guessing. So we take a small step downhill, recompute the slope, take another step. Every single step lowers the cost a little. The line gets better each time. One thing to get right, the step size. Steps too big and you leap right over the bottom and bounce around. Steps too small and it takes forever. So we pick a sensible step. We keep stepping until the ground goes flat. The slope is basically zero. That flat spot is the bottom of the valley. The dials are now tuned. The model is trained.
So the fancy words gradient descent really just mean roll downhill?
That's genuinely it. We built a valley out of the error and we roll to the bottom. Big name, simple idea. So far, our example was one number in, one number out. Real data is a huge grid of numbers. Next, why everything inside a computer is a matrix.